Hi, and welcome to Codeless Pipelines with Pulsar and Flink. This is my talk here at DataCon LA. I'm Timothy Spann. I'm a developer advocate at StreamNative. We're the company that does Apache Pulsar. Today, I'm going to show you how you can easily use Apache Pulsar, Apache Flink, Apache nifi, other Apache streaming tools to do very easy codeless pipelines from regardless of where your data is. Today example, I'll show you IoT. If I have time, I'll show you some other data sources. The good thing is it doesn't really matter. The flexibility is there, whether you want to use native Pulsar protocols or you already have existing clients or producers out there that are doing things like MQTT or JMS or REST or Kafka or some other legacy protocol. Pulsar supports those, and we'll show you how easy it is to get your data flowing regardless of the source. I'll just show you an easy one with some IoT sensors getting fed in and going right into Pulsar, where we could do with whatever we want with it. In this example, I'll show you it being ingested to a cloud database, and I'll show you that same data seamlessly going into Flink as a table, and I'll let you do some pretty impressive things very easily. So let's get to it. So we'll show you an example application. This could have been a messaging application from any kind of third-party system or a mobile app, phone, what have you, or a standard data pipeline, or you're trying to get some real-time context out of data. I'll show you a little bit on how we do that. Underneath the covers, there's a powerful storage layer. What's nice with Pulsar is we have that separation of compute and storage, which is so critical in native cloud applications. This also lets you decide if you need to stream some of that data storage to cheaper storage, such as Amazon S3. And you can run that wherever you need to run it, whether it's in Amazon or Microsoft or Google or Alibaba, or just in your own Kubernetes environment. Makes it very easy for you to get this up and running and not have to worry about how you're managing it. Today for the demo, I'm running it on my laptop. I'll show you how easy that is. I've got all the directions there, all that's in open source to make this really easy experience for you. So I've been doing this for a while with different technologies in the streaming space. You might have seen me at Cloudera or Hortonworks or Pivotal doing various things with streaming tech. This is the latest iteration. I think this is the most powerful I've ever worked with. Also, for people who don't want to write too much code, it makes it very powerful still. You have lots of different sources and syncs you could work with all the power that you need for applications. So I've coined two stacks of projects that work really well together. One is Flink, that's Flink, nifi, and Kafka. The other is Flip, Flink, Pulsar, and sometimes we put Pinot in there. Sometimes we put some other things. Very powerful stacks here, but makes it pretty easy. Again, everyone wants to see textual data. Here's some JSON. This is our typical event data that's coming from a device. If you see here, it's got a unique ID, and it's got various sensor readings. Also have some timestamps that are useful for doing different kind of queries later. What's nice is once I get it into a topic, Flink will add its own timestamps for me. Gives me that extra layer of possibility if I want to do windows on data or other things that involve with looking at chunks of data as it moves through the system in time. So that's a different thing when you're thinking of SQL against a static source for SQL against data that's in the event, in the now. You have to think of, do I want to just see this, what happened this second, or do I want to see what happened in the last minute? You have to start thinking of when you want your data, not just what the data is. So now you're dealing with another dimension, which is powerful, but it's something to think about. So in today's example, Got a bunch of different data sources. We'll see how much time we have. But the main one is I have a device sitting here on my desk. It is gathering data from a number of sensors in this room here. It's feeding them through Kafka topics and through MQTT. What that Python script doesn't know is, yes, it's using those appropriate protocols, but it's going through my Pulsar cluster here, and that's feeding into a Pulsar topic, which we'll be able to read with nifi and Flink, and we'll do some additional processing now that it's off of that box. The nice thing is when I start scaling this out and say I need 100 devices or 1,000, 10,000, 100,000 devices scattered along the world, those can all come in through different protocols, come into my geo-replicated cluster, and I can run these SQL analytics on them, or just use simple things like sync. So I could have Pulsar push that into things like InfluxDB, Aerospike, just into S3 buckets, tons of different syncs there. You can look at the hub at StreamNative to get an idea there. So pretty straightforward. What's nice here is sometimes I want to use nifi in that first spot. So we could do some cleanup, validation of the data. That way I don't have to write a code. I could just have a source pointing to something, but if it needs extra validation, it needs to combine with other data. Maybe it's running an NLP process or Tika to pull out tables from a PDF, maybe run some deep learning on it. nifi makes that pretty easy without code. If you're happy doing code, I could do that with Pulsar functions, with Java, Go, or other languages. And I could also do some of that processing later in Flink with Java or Scala, very powerful processing there. So I've got this data in, I could dump it into a data store. I'm dumping it into a cloud database, could dump it into an object store, or I could just have it go right into Flink, never store it. Never have a permanent store other than Bookkeeper and Pulsar as part of that, event stream of topics, and just run my queries on it, do alerts, do whatever processing I need to do, and then go about my way. I don't have to think of a permanent data store if that's not needed for the app. It might just be looking for sensor anomalies, and I could just keep tracking that as it happens in event time. So to do this, show you under the covers, I have an application. It's a very simple Python IoT app. It's reading all the sensors attached to that device. And then when it's done, formats that as JSON. And here I could show you how easy it is dumping that into MQTT, where that is an MQTT client code. And if you look at that topic, if you know MQTT, that may seem a little odd because that's a Pulsar topic telling me it's a persistent topic and where it is within the namespace. And that lets me push that right into Pulsar. I don't have to have a Pulsar specific client on that application. I don't have to rewrite it. This was existing code I had that used a legacy MQTT broker. Don't have to change anything. I changed the topic just to make it easier for me. And then I'm also sending that same data to Kafka. But again, it's not really Kafka. If you look at that IP address, it's the same cluster that is sitting on my laptop, receiving both types of messages, and they're just natively having them in their own topics. I can install the libraries I need pretty easily in Python. Again, if you don't want to do Pulsar on that, or if you already were using Kafka, MQTT, or something else, this lets you have that native protocol and not have to worry about rewriting all these existing apps, which could be painful if you've got things deployed out in the field. You just update where you're connecting to, or put it behind the gateway and have Pulsar do the rest for you. Pretty easy. I have this process really well documented on my GitHub, so you can just go there and get the code. You don't have to worry about how could I do this. And if you want, you'd either run it natively in the cloud, you can run it all in a couple Docker containers. I'm running Pulsar and Flink standalone, and I'll show you those running. Same with nifi. Got enough RAM, you can run it wherever you want. Again, easy to run it in the cloud. I've also have a couple adapters on there. One we call MOP, which I think is funny, and then COP. These are the ones that let me use those different protocols. So again, you don't have to convert everything to Pulsar to be able to use it in your codeless pipelines, which is pretty awesome. Just to show you, before we get to the demo, some of the screens, this is an example of how nifi is interacting with my different data streams. Consume it natively from Pulsar using my friend David's processor there, or we could just consume it as if it was Kafka, because I have that KOP on there. Important thing to know is Apache Pulsar is cloud native, and it's messaging, which we mentioned because MQTT is not event streaming. But we could do event streaming as if it was Kafka. So it gives you that power regardless of what you want to do with these messages, whether, everyone is consuming the same message, you want everyone to get a subset. There's so many options there that gives you the power to run, your typical JMS style messages or your Kafka style, which is very important. Geo-replication is built in from the start. So if you need to scale out, or in IoT, you may be collecting this data in different parts of the US or different parts of the world. This makes it easy to not have to do the heavy lifting yourself to figure that out. That is in there natively. You don't have to do much to configure that. Sometimes you want some code to happen automatically when messages come into topics. Pulsar functions let you do this very straightforward in a couple different languages, which is nice. You need to scale out. This isn't just for small applications. I could scale this as big as I want. What's nice here is built in is multi-tenancy. So I could have namespaces and I could keep things separate. So I could use one cluster for a lot of different companies or a lot of different groups within my company. Just keep them separate so you don't have to worry about security or collisions or anything like that, all separate. We mentioned the tiered persistent storage. Sometimes you're going to run out of space. The brokers running Pulsar, those are just for compute. The Apache bookkeepers that do the storage, again, you might not want it on that maybe more expensive storage. Maybe that's SSD for speed. You get some older messages. Do I want to get rid of them? Do I want to be able to maybe do queries back on older data? Do I want to have to make these supersized nodes? No, let me get that into S3, which is inexpensive and lets me scale this out as big as I need to. What's nice is we mentioned these connectors. So if I want to automatically have, this data as it comes in gets stored into Aerospike or InfluxDB or Solar or Elastic or HDFS or HBase. There's so many. And if you don't see one you want, the API there is really straightforward. You could add your own, connect to things like any JDBC store, CockroachDB, any of those different databases out there, because there's a lot and they're all pretty awesome. If you have one already, you don't have to get rid of them. They got those native connectors there. Everyone likes to do REST. I'll show you a couple of REST endpoints for monitoring things going on. Very easy to access whatever you need to do there, and do actions on there. So if you want to hook that up to your DevOps, it's set up to do it like that, or you could do it through the command line. Lots of capabilities there. You can automate as much of this as you want, or just go the easy route, have someone like StreamNative do that hosting and management for you. Lots of different clients out there. Again, what's nice is because we have those other protocols, if you're already using MQTT or AMQP or something else, you could use those drivers already. But to make it easier, we have clients for Java, for Go, for Python, Node.js, tons of different ones. Or you could use the REST API. Lots of ways to get your data in and out of Pulsar. Lots of ways to subscribe to data. It's not just one style. You could do a full talk on that. We have a bunch of those on the website. And my friend David does a lot of good ones on that. We won't get into that now. Again, support for different protocols. So if you don't want to do Pulsar format, maybe you're not ready to change all your clients yet. Whatever one you have, we probably support that. Makes that very straightforward. So when you're ready, you slowly add all the new apps onto that. And maybe as apps get sunset, you don't worry about it. If they do have to be upgraded, you could just switch to Pulsar pretty painlessly. Again, there's a couple of reasons why to use Pulsar. To me, the scalability and having that one messaging model, regardless of what style you're doing, regardless of what protocol, that makes things so easy, especially with codeless, where you don't want to have to write a lot of code and you don't want to think, well, what happens if I move to another kind of messaging? Or what if I have 3 different messaging systems now? How do I integrate that? How do I get messages between them? Am I making duplicates? And how do things get lost? How's security? Just do that in one place. Pretty straightforward. Flip is the name for Flink plus Pulsar. The two together work really nicely. Again, great Apache projects for doing, all the different kinds of compute you need to do, and with a lot of power and scalability. Flink has been one of the projects I've liked for a long time. Being able to do this distributed processing without having to, get stuck on some weird syntax. The syntax is very clean, writes very fast. It's real time. It's not doing micro batch. You could do exactly once for a lot of different use cases. I really like Flink and Pulsar together. Really powerful way to write modern cloud native applications. We've got a lot of different ways to keep in touch with us. You're interested in the project. We've got Slack, we've got Twitter, all those things that you expect. I've got some links so you could dive deeper into this examples and to learn more. And we'll make sure you get these slides. But let's show you some actual code. Yeah, this looks great. This is the one of those REST endpoints. I just wanted to show you how easy it was to get different things. This is the topic we're looking at. If you open and leave this REST endpoint on, or you have it locked down, you could get this information. I could pull it in with something with nifi and programmatically see, okay, what's going on, how many messages are out there, all that kind of rich metric data is available. You get it through REST, you get it through Grafana, or however way you want to get this sort of data. Pulsar is really open to have that. It's been working on these things for a while, so you have all the visibility you need to safely run these clusters and do it in a clean way. Here, what's cool is if I want to be able to look at the data or read it from REST, maybe I'm in a browser, maybe I'm in a phone, and I don't have a native Pulsar client, or I don't really want to use one there, I could read messages via REST. See, this is so if I wanted to change the topic, obviously you'd have security if you're not running on your laptop. Yeah, I picked one that's not there. But yeah, you have to have it set up a subscription. That subscription lets you access different things within topics. Not the most interesting message there. This one's a little cleaner because it's got JSON. Again, you can also enforce things with schemas. Gives you an idea what's going on. I'm going to go to everyone's favorite place now, the command line. First, I'm going to run my Flink cluster. Remember, I said I'm running this locally. I have Flink running here in a 1-node cluster. Over here, I've got my command line interface into Pulsar, just to show you how easy that is. We said you could do things in the command line. Tons of different options here. I'm just consuming a message from that topic there. I've got that running. Let me start sending my streams of data. This is that fancy IoT device. It's just going to be sending messages out there, but I wanted to make sure we start getting some messages. And then within Flink, I'll create a table so we could start seeing and querying that data. Let's get that data, and then we can start doing that process. So we come over here, and I'm going to grab the syntax for that table. Let's make sure we're not in full screen. We don't need that here. So if you see, that's within my GitHub. I've got the syntax to create a table. Pretty straightforward. If you've created a table before in anything, say Postgres, looks familiar other than the bottom. There's a couple of special syntax for creating these tables in Flink. As you can see, it kind of makes sense. There's the topic. What's the format of the value? We're using the Pulsar connector. Where's the URLs I need to connect to? And when do I want to start getting that data? For me, I want to get it, all the data that I can get that's in there. I create this table. Now here I can make sure it got created. I could describe that table. Again, command line, easy way to interface to this. Well, you could also do this cloud native web clients, or I could take whatever I'm doing here. This is where I'm exploring what queries I want to run. And I can embed this in a Flink application and deploy that to a big cluster and just have it running. But just to show you as an example, I'm just going to select everything from that. And while that's running, again, all the information you need to set it up is in here. I'm going to run that, have that start coming up in Flink. Now we have another example. I could use the StreamNative cloud to do it. Here, this makes it really easy to see what's going on with your topics. You just browse through in there with a subscription, like you saw in the REST endpoint. What's nice here is if I have a schema, you can see it here. Again, typically we're working with schemas if I'm writing applications with code. And, if I wanted a different interface to Flink, I could come through here, pick out my catalog, get my data, find out what tables I have, and do it that way. Just another option. Depends on what makes sense for me. Command line interface, I'm using that so you could run that at home. Makes it easy. As you see, data's coming in because I have that IoT app just running. You see, every time you see a new line there, that is a new row that's been added. So this is real-time continuous SQL. So if in my SQL I said, insert into another topic. So say I'm looking for something. So say select when, let's look at one of these rows. Maybe I'm going to look at one of the sensor readings. If, say, the CPU temperature goes over 43 Celsius, I want something to happen. So I could just insert that into another topic. I could have that go right into, say, an Aerospike database, or there might be a consumer application, whether it's a Flink app, a Spring Boot app, a Go app, whatever it is running somewhere, waiting to consume that message, and then do an alert. I can do that. Pretty straightforward. If you see, we've got 15 pages of data. Very easy for me to page through those. Just go to the current one. As you see, it's just as that data is getting pushed out. Again, my IoT is pushing it into an MQTT broker, which is in reality Pulsar. And then I can natively read that with Flink SQL as more data is getting read in. And you could do a lot here. I could do only show certain fields I want, do a window of time. So let me do a sum or an average. Maybe I'm looking for deviations in that. And I could do that with really basic SQL. And if I want to make that into a full app, I can embed that in Flink and have that do whatever it needs to do pretty easily. So that's just an option there. And we'll let that Flink app run just to show you, some more data as it comes in. Now that data, why you use something like Pulsar. Sure, I want to use it in Flink, but I also want to use it in other parts of my Codeless pipeline. I could do it all in Pulsar. I could have Pulsar have a sync for Postgres. I could have a sync for, like I said, there's a ton of different syncs out there. I could have Pulsar sending it to 25 different data stores spread around different clouds and wherever they may be. But I want to show you some other ways to interact with this data in a codeless way. So I'm going to consume that data from that topic here, connecting to the local pulsar, that same topic. And I'm just going to have nifi consume it. And we could see how easy that is. Again, no code there. And I could see the data is coming in, how many messages at a time, unique ID. And I could take a look at the actual data. And I could see that's that JSON data I saw before. So it's coming in fine. And that's through using the native Pulsar protocols that nifi can communicate with. I can also interact with that Pulsar cluster through native Kafka protocol. So this one's looking at that Kafka topic that I'm also pushing to. Again, makes it easy for you to change out what you're doing without changing any of the code in that application that you may already have written that used Kafka. And here it's got all those things you expect to see in Kafka, like offsets and partitions, but under the covers, we're still just hitting Pulsar, but we're getting that same data we wanted there. Again, gives you options on how you can consume and produce data. Pretty straightforward. To show you some of the nifi bits, these three little boxes here in a codeless paradigm are taking the data out of that topic. Here, I am running a query on it as it comes in. Again, I didn't have anything to write here, but I could do things like we just mentioned in the Flink side. I could run some analytics on there. Maybe just I want a couple of the fields. That's the easy way to transform the data. And here I'm converting it to JSON, which is the same as it was, but I could turn it into Avro or into a comma separated value. Maybe I'm going to put it into Parquet, and then I'm going to dump that into a Lakehouse from Databricks. You know, lots of different options there. Or maybe I needed an XML for some legacy app. I could do that. Gives you a couple of options. And here I could write a query. I could write as many queries as I want. So if I wanted to write a query for alerts, I could do, you know, maybe I just want a couple of the fields, you know, from this. And I could just do where clause, where say the temperature was greater than 50. And then I'm going to send that somewhere else. Maybe I'll push that to a Slack channel, push that to another data store. You get the idea. What's nice here with nifi, you can see the data is coming in continuously. The fact that I stop something to change it doesn't make me lose data. I've got a configurable queue here with built-in load balancing. It's just going to wait till I restart it. If I run out of space in this queue and I don't want it to automatically increase, this will stop consuming until this is available. Nice feature so you don't have to worry about what happens if you're missing data. Here I've got a connection to Postgres. If you look, I didn't have to write any SQL. It takes that JSON and maps it to an insert statement. And then it gets stored here in a cloud Postgres SQL database. Let's just do a quick sort on here, see what data we have coming in. Maybe we could do it by system time. I'm going to do last 250 records. And you can just see that data coming in as we're getting it pushed in. Pretty straightforward, but this is all you need to do. Again, I could have set up a Pulsar sync to push to the same JDBC store, but you know, this lets me do some little changes on that. I've got a lot of different things I could do. Maybe I could do some NLP on there. I've got some things to do some deep learning on that. Maybe I just want to do some text cleanup. Maybe I want to just do some minor modifications or drop fields out. You know, maybe only need some of those fields. If we look at the data as it's coming in through the lineage here, I could look at it and see that, you know, maybe I don't need all these fields. You know, maybe I don't care about amplitude, you know, because maybe that doesn't change. Or maybe I don't care about the MAC address. You know, that's useful for me debugging all my IoT devices, Here, disk space, maybe I don't care about the disk space of that device, but I really care about the CPU temperature. I really care about the ambient temperature around that device, or there may be one sensor on here more important than others. The humidity is really important in this data center. So if it goes above a certain percentage, then I need to send out an alert. So maybe I'm just going to grab humidity. That might be really important for me. So, I can just grab out humidity and do something with that. So like here, I might want to send this to some other processing to do something. So I'm going to stop this again, not lose any data. And I'm going to add another query. This one's going to be an alert. So let's select just humidity, unique ID, and what was the other one? System time, maybe. System time's a good one. You put that in there. System time from that flow file where, I don't know, humidity is, we'll do it as, we do it as an int, whereas a float is greater than like, say 20. That's pretty, that's pretty low humidity. But just to give you an idea, fortunately, I have my office here pretty temperature controlled. So let's run this. Hopefully I wrote my query right. As you can see, the the humidity is definitely above that. And if we look at the output here, it's just those fields I picked: humidity, that unique ID, and system time. So I've written something that created a custom JSON, which could be another one. I can make it XML or CSV or Parquet or Avro that just has those fields where it's greater than some value or it's through a range. What's nice is the SQL inside of nifi and the SQL inside of Flink is all based on Apache Pulsar, which is an amazing Apache project out there for doing really complex SQL very easily. So it's nice to have that. So what we're looking at, humidity, we want system time. Maybe I wanted adjusted temperature. I do some math on there to correct for the temperature of the device. So the temperature is not kind of crazy. I've got it in Celsius and Fahrenheit. Because I'm American, I'm not good at knowing what temperature Celsius is. I should know that by now, but that's what you get with a public education. So we'll write another query here. And while that's going, so I could have this alert. I could do something like, say I wanted to push that to a Slack channel. I could push that to a Slack channel. We've got a lot of different options here. Again, maybe I'll send it to another Pulsar topic. Again, when you see things that are going from Pulsar to Pulsar, it makes me think, well, maybe I should write a very simple Pulsar function, a couple lines of Java, a couple lines of Go or something, pretty straightforward. Maybe I should think about that. Again, that's up to you. I've done some nifi if you look out there. So I kind of like nifi and it's pretty easy, especially if I want to minimize the code I'm running. That's up to you if you want to write more or less code. I really don't care until it's above 50. So I'm going to change that. Probably not going to get any records now unless it gets really hot in here. And again, if I want to change what fields are coming out of there, again, if you created a schema, you can control that. Maybe I want that adjusted temp. I think that's the right spelling. Should copy it so I don't screw that up, but there shouldn't be any new data. Oh, what is that humidity at? Should check that out. Oh, I broke the code there. That seemed a little odd that it was doing that. Got to be able to spell things correctly. But yeah, let's do 45. Run that. Shouldn't be any more there. But yeah, you got a couple different options. We're pushing some to tables, pushing some to Flink. Here now you can see we have less data over here. It's just the fields that we added. Again, SQL is pretty straightforward. We could have done things like do a sum. Maybe I want to do an average on temperature over the last period of time. Maybe I want to do a rolling sum. Doesn't really make sense with this data. Some other data it does, where maybe sometimes for certain sensors, they will just give you the offset, the addition from some known number from some time period. You could code that in your SQL, figure that out. Again, humidity, pretty consistent. Also there's some how sensitive the sensors are. It gives you an idea there. Pretty easy to write your own queries. Whatever you want to do there. It's just a nice way to do that. What's nice here too, I don't think I set up a registry, but if you set up registries, you can have different ways. Like if I look at the Pulsar catalog, there's a bunch of tables there. Those are automatically created based on the ones that are in Pulsar. I created mine in the default one, so I have more control over that. We call it default catalog. Default _ catalog. And I don't like when people use defaults and underscores. But there you go. We have that just that one table. We create more if we needed to, just to give you an idea. So we have all that running. I did say I wanted to show you another kind of data if I had time. I have in here something that's reading stock data off of a REST endpoint. Pretty cool data source. Again, just looking at some different stock. Here I can use nifi to update it. So here I'm adding a timestamp where it didn't have one. I'm adding the stock symbol. Somehow the record didn't have that. And I had a unique ID. nifi can generate a unique one for me. And then here I'm splitting them out just so I can control how much data is going into the system at once. Just makes it easier for me to watch it. Otherwise, as you see, I just ran 10,000 records in a second, which is nice for me processing. Not interesting, not good for you wanting and watching a demo because the records are gone already. It just came through the system. So, I mean, it's really fast there. But it doesn't really matter what the data is or where it came from. Here I'm just looking at the data and then we just pass it through. And then I could just send it to another Pulsar topic. I could send it to a data store, wherever you want to go with the data. And here I'm consuming it, putting in another database. Gives you that same idea. Doesn't matter what the data is. It's pretty straightforward for us. So I hope you liked my talk. I'll have another one in a couple weeks in virtual Europe. And that one is on a similar topic. Should have some more deeper examples, working with a couple of our people on some interesting data sources they have. So hopefully we'll get to see another cool talk there. If you want to try this out, we have that all on the cloud. I hope you liked my talk today. Thank you, and enjoy the rest of the talks at DataCon LA. Thanks again for having me.